Hello, and welcome to this introduction to chemical naming. Here we're going to be looking at how we name chemical compounds and what the rules are. So the name of a chemical compound tells us which elements are in it. And if compounds are only made from two elements, we change the ending of the second element to "-ide" to tell us that it's chemically combined. So if we have a look at some examples, here we have MgO, which contains magnesium and oxygen. That becomes magnesium, and then we change the ending of the oxygen to "-ide, so we get magnesium oxide. Here we have sodium and chlorine. The name of the metal stays the same, sodium. The chlorine changes to chloride, giving us sodium chloride. Similarly, here we have potassium with chlorine. So the name of that becomes potassium chloride. In CaBr2, this is the first time that we've met numbers in a compound. Okay, the numbers are simply there to tell us the ratio of the number of each type of atoms that appear in the formula. We'll be looking at how we work out these numbers when we do this in the formula video. However, for naming, we typically ignore the numbers and we still just look at what the elements are. So here we have calcium with bromine. So the name becomes calcium bromide. Here, Al2O3, again we ignore the numbers and it becomes aluminium oxide. So the thing to remember, change the name of the second element to "-ide". Okay, over to you. I'd like you to pause the video and try these examples. Pause now. Let's have a look at what the answers should be. We should have hydrogen chloride. We should have calcium oxide, lithium chloride, sodium oxide, ignoring that too, it doesn't feature in the name, and aluminium bromide. Okay, so now you can name compounds containing two elements. However, things can get a bit more complicated with oxygen. Now, previously we looked at aluminium oxide, Al2O3. Here there is only one option for how many oxygens come combined with those aluminiums, and they always come in a ratio of 2 aluminiums to 3 oxygens. So we don't need to include anything special in the name. But some elements, so typically carbon, nitrogen and sulfur, are able to form different compounds where they combine with different numbers of oxygens. So to enable us to tell them apart, we have to include the number of oxygens in the name. So if we have one oxygen, we use a mon, so it becomes monoxide. If we have two oxygens, it's di, so it becomes dioxide. And if it's 3 oxygens, it's tri, so it becomes trioxide. Let's take a look at these examples. This here, carbon with 1 oxygen, is carbon monoxide, a poisonous gas that you need to know about. Here, carbon can come with 2 oxygens, so this becomes carbon dioxide, which I'm sure everyone has heard of. It's the gas that we breathe out, which contributes to the greenhouse effect. SO3, this is sulfur with 3 oxygens, so this becomes sulfur trioxide. So here you can see mon for 1, di for 2, tri for 3. We still just have the oxide ending, but that goes in front to describe how many there are. Here are some examples for you to try. Pause now. NO is nitrogen monoxide. SO2 is sulfur dioxide, and NO2 is nitrogen dioxide. Okay, so there you have the variants with 2 elements in the name. Now you have to be able to name examples with 3 elements, where one of those 3 elements is oxygen. And the ending of the second element changes to 8 to show that oxygen is present. Let's take a look at some examples. So CuSO4, we have copper. If it was just sulfur, it would be sulfide, but now to show that we have oxygen present as well, that becomes copper sulfate. Okay, the ending is 8, which shows the presence of the oxygen. What isn't reflected in the name is how many oxygens there are, and there are examples of these that you just have to learn, but that will come in the formula video. So we ignore that for now. KNO3, that becomes potassium. Nitrogen becomes nitrate, with that H showing us the oxygen. This is calcium carbonate. Okay, so CO3 is carbonate, showing us it's carbon plus oxygen. Okay, some examples for you to try. Pause now. Right, let's take a look at the answers. This is sodium nitrate, calcium carbonate, which I think you may have actually had as one of the earlier examples, iron sulfate, sodium carbonate, and sodium sulfate. Now you will learn that there are extensions to these basic naming rules. So when we look at transition elements, we actually have to give the oxidation state the charge of the transition element because they can form ions with different charges. There will be more on that later, but here this Fe is actually Fe2+, so this would be iron 2 sulfate, showing us that it's an iron 2 ion. But don't worry if that's going beyond you at the moment, but just to introduce that little extension. Now, there are more interesting names, and there's some common compounds which we come across in chemistry where you just have to know what the names are. And this covers most of the common examples. So OH is hydroxide. This is therefore sodium hydroxide. It is an alkali. When hydrogen chloride dissolves in water and becomes aqueous, it becomes known as hydrochloric acid. This is a strong acid. All acids begin with H. So here we have 2 more acids because they both begin with H. HNO3 is nitric acid, and H2SO4 is sulfuric acid. NH3, that is known as ammonia. It is another example of an alkali. Ammonia reacts with hydrochloric acid to give us this compound NH4Cl. Ammonia changes its name slightly to become ammonium and then chloride on the end, as you would expect. Great, so that's your introduction to naming. Bye.